This demo will showcase the integration between the i2Edge and the intelligent placement algorithm. The objective of this demo is to deploy and integrate an intelligent placement algorithm tailored for multi-AGV environments. The demonstration will provide a detailed walkthrough of the steps taken to perform placement decisions, highlighting the logic and processes involved in the approach within the orchestrator framework. i2Edge is designed to manage the lifecycle of industrial applications, enabling zero-touch deployment and optimizing performance by placing applications closer to data sources and end users. The integration between i2Edge and the intelligent placement algorithm is illustrated in the block diagram, showcasing how the data from i2Edge, including resource requirements and node specifications, flows through a normalization module to produce normalized values. These values are then used by the multi-AGV request placement algorithm to select the most appropriate node. The intelligent model implements a dueling deep queue network, DQN, designed to learn optimal policies in complex environments. Its structure focuses on efficiently calculating the values associated with each possible action in a state, improving both precision and stability in learning. It processes environment states through dense layers that extract relevant features and separates the computation into two streams: the value stream, which estimates the overall worth of being in a specific state, and the advantage stream, which evaluates the relative benefit of each action in that state. These streams are combined to compute Q values, ensuring that the model effectively balances general state value with the specific impact of individual actions, enabling it to decide the best action to take. Now, a hands-on deployment is going to be shown to showcase the integration between the i2Edge and the intelligent placement algorithm. We will invoke the API to perform an intelligent deployment. This API we'll call the DQN model, which will determine the optimal AGV where the information will be deployed. Then we will pass this information to i2Edge, which will handle the deployment of the application. On the left side of the screen, you will see the i2Edge user interface, which we will use to interact and deploy the applications. On the right side, you will see the steps taken by the intelligent model to decide the placement of the application. For this demo, the application to be deployed called i2Edge chart has already been pre-onboarded in the i2Edge. Additionally, two deployment flavors have been created, specifying the application's requirements for disk, RAM, CPU, and GPU. One flavor includes GPU resources, and the other does not. To proceed with the i2Edge chart deployment, we simply need to include the flavor ID, the application ID, the zone ID, and the namespace where the application should be deployed. The normalize information method prepares the input format required by the DQN model for decision-making. It normalizes the resource metrics of computing nodes, such as CPU, memory, GPU number, relative to their capacities, and scales application demands based on total available resources. The result is a structured NumPy array representing the state of the system and its requirements, providing a consistent and comparable input for the DQN model to make informed resource allocation decisions. As shown in the output log, the application has been successfully deployed on the selected node and in the test space 1. This can also be verified using the Lens user interface. Last, we will follow the same procedure for the application flavor that requires GPU resources. For this application, the node 6GXR-worker 2-GPU is selected due to its GPU capabilities. That concludes the demo. If you have any questions, please don't hesitate to ask.